Good morning, students. How are you? Today, I'm going to solve some problems from grade 8 ministry examination, okay, primary school living regional examination. It is actually the Amara National Regional State Bureau of Education in 2010, okay? The 2010 primary school living regional examination of physics. So when you see this video, okay, what you do is you have to have the exam paper from the physics exam paper from 2010, okay, 2010, 4 years ago. Okay, you have to have that, and I will read the problem and I will solve the problem. But to solve the problems, what I do first is I will explain concepts related to the problems. That's the main idea. My focus is not the solutions or the answers, okay? My focus is how you can use the definitions, techniques, principles, and laws. You learn it from your class and apply those to answer or solve problems or questions. Okay? So let me read you the first question. The first question says, which of the following branches of physics studies about production, transmission, and other properties of light? Okay? So before I go to the multiple choices, let me discuss briefly about branches of physics. Okay, physics, as we know, is one branch of natural science which studies about nature in general and properties of objects, their motion, energy, structure, volume, shape, mass, weight, interaction with others, and so on. Okay, so physics in general is the state of matter and energy and their interconversion, which says energy can be converted into mass and mass can also be converted into energy. The conversion of mass into energy is common in our day-to-day lives. When we burn wood, when we make fire from fuel, when we make fire from gas, charcoal, whatsoever, we are doing an activity which converts matter into energy. Okay, and the reverse is not a common science actually, but it is true that energy can be converted into matter or mass. Okay, so physics has different branches. Branch of physics are mechanics, which is commonly discussed at the very beginning of physics subjects. Okay, mechanics is one branch of physics which deals about motion and the cause of motion of bodies. Okay, it deals or studies about, or it is concerned about motion of bodies and the cause of motion. The cause of motion. So mechanics can be divided into kinematics, okay, kinematics and dynamics. So under kinematics, we usually focus on how motion happens. How? Okay, we don't know why, but how? Is it moving faster or slower? Is it accelerating or decelerating? Or is it at rest? Or is it in motion? Okay, such kinds. How long it stayed in motion? How far it moved? And all this can be answered using equations. And those equations are developed from definitions, principles, and laws, and they are going to be under kinematics. So kinematics is the how and what, okay, we can say and what of motion. It tells you how an object is moving and what distance it covered, what velocity it has, how long it stayed, okay, the time it takes, or the time it has taken to cover a given distance, and so on. Okay, the how is how it's fast. Is it moving faster, slower, accelerating, decelerating? Is it at rest? Is it moving with constant velocity? All those are under the how. And what? When we need to know about the numerical values of the physical quantities. Okay? So you have kinematics, and dynamics is the y of motion. Basically, here you will answer the question why bodies move. Okay? Why bodies stop from moving? Why bodies change direction from motion, which is in general due to or because of force. Okay? So when we deal about force and momentum, impulse, work, energy, power, pressure, and so on, we are under the branch of mechanics, specifically dynamics. Okay, so this is the first branch of physics. The other branch of physics is electricity and magnetism. Electricity and magnetism. Here, electricity and magnetism were separate branches of physics. Electricity related to electric charge and electrical energy. And magnetism is about magnets. It deals about magnets, natural magnets, man-made magnets, okay, magnetic polarities, magnetic force, and about magnetic and non-magnetic substances. Under electricity, we can talk about electric force, electric potential, electric energy as well. And in 1820, because of the discovery of what we call electric current produces magnetic field, like electromagnet, okay? So what came up is these two branches merge together. They become one. And we have one branch which is electricity and magnetism. And it deals about electricity related and magnetism related concepts as a whole. And usually we treat them a little bit separately and we merge them together after electromagnetic induction. When it comes to the third branch of physics is nuclear physics. Under this one, it is all about the beginning of modern physics. There were questions. Those cannot be answered with mechanics. Okay, when you go to the kinematics and dynamics of very small particles, atomic level particles, molecules, electrons, and protons, you can't answer those questions based on mechanics, because mechanics deals about bigger objects, and those bigger objects are observable with no aid or with no assisting materials or devices. But when physics came up with questions like what looks like the structure of the atom, how it behaves, and so on. And when radiation from radioactive nucleus and nuclides was discovered, the main question is raised. When bodies radiate energy like electromagnetic wave, those questions cannot be answered with mechanics. Therefore, modern physics comes up, and the first one actually, which is the bridge, okay, the bridge between mechanics and modern physics. The old one, the Newtonian mechanics and the quantum mechanics, comes up with nuclear physics. So nuclear physics is about the nucleus of atoms, about black body radiation, about relativity. Okay, relativity comes next to nuclear physics under the discussion of modern physics. Okay, so nuclear physics is about nucleus of, okay, nucleus of atoms, and it is also about radioactivity. It is also about radioactive decay. Which is helpful to study the age of fossils. Okay, it is also studies about radiation types: gamma radiation, alpha radiation, beta radiation, about X-rays, and so on. Okay, about radiation. Okay, so nuclear physics is all about this and some others, and some more. So we have mechanics, we have electrics and magnetism, we have nuclear physics, and we have some more, like we can say we have optics. Optics, it is all about light, okay? It is all about light. It tells you about how light propagates in a medium. It tells you how cameras or optical instruments work, how optical instruments like camera, telescope, whatsoever work, and it tells you how you can deal with images made by lenses, images made by mirrors. It tells you about substance as well as translucent, transparent, opaque, and so on. It deals about source of light as well. Okay, it deals about source of light. The other one is, it can be astronomy, astrophysics. Astrophysics is a big branch of physics which deals about astronomical objects like planets, stars, asteroids, comets, and so on. Okay, it's all about our solar system, galaxies, and in general about the universe and the cosmos. It is about planets, stars, galaxies, and so on. Okay, and so on. And the other one can be space physics. Space physics is about the region from 60-kilometer altitude to the sun. So it tells us about interaction of sun and earth. Earth-sun interaction. Okay, you can have also atmospheric physics, and there are many more branches. These are the commonly discussed branches of physics. So when we come to the question, which says, about Okay, you can see the choices are mechanics, optics, electricity and magnetism, and nuclear physics. The question says which of the following branches of physics studies about production, transmission, and other properties of light? From our discussion, it is automatic that optics is related to light production and transmission. So the answer is B. Based on what? Based on the descriptions of branches of physics. So whenever we get such questions, just focus on our discussion and use the discussion points and try to relate the choices to that, and you can answer it easily. Okay, so this all about the first question. When we go to the second question says, which of the following sets of physical quantities consists of derived quantities only? Derived quantities only. Yeah, the answer may be simple. You can answer it automatically by reading one after the other, the multiple choices. But my objective, as I told you, is what are we going to use as a basis to answer the question. Okay, so you start from physical quantities. Physical quantities, you have to define them. We have defined them in America, actually, in the previous videos. But physical quantities are, we can say, things around us which we can measure them directly or indirectly and use to describe what we call an object, a thing, or a phenomenon, or a process, or an event. Okay, it tells you maybe the related truth related to a process, an event, or object, or maybe a phenomenon. Okay, so they are very important to study nature, and they can be described. They can be described in two ways. One way, we can put a number and a unit, and so that it can be complete. And the other way is we need a number and a unit, and as well a direction, a specific direction, so that the physical quantity can be completely described, okay, fully described. But that is one way of dividing physical quantities, and we can have the first two is scalars, the second type is vectors. And there is another way, actually. For the sake of simplicity and to have a common understanding of nature, scientists have developed two types of physical quantities. One type, which are specified in number, which are 7 in number, are associated to some physical phenomenon and said to be fundamental. And their SI units are also said to be fundamental. Those physical quantities are, the fundamental physical quantities are time, okay? Second is its SI unit, but fundamental is international SI unit in the system of international units. Then we have length, okay? And we have mass. These are under mechanics, okay? And you have temperature, actually in heat and thermodynamics. And we have current and electric current, under electricity and magnetism. And we have what we call luminous intensity. It is from optics, basically, we can say. And we have the last one, amount of substance, which is related to bulk matter, basically. So we have here second as international system of units for time, length as meter is its SI unit, international system of unit, mass kilometer, okay, kilogram, sorry, temperature Kelvin, current ampere, luminous intensity candela, and amount of substance mole. Okay, mole. These SI units are fundamental as well, and they are associated to, as I told you, to some fundamental physical processes, some natural process or events or objects. Okay, the rest you call any physical quantity. It is derived, okay, by either multiplying or dividing these two of them, three of them, or more of them. Okay, like for example, you can have velocity. Okay, velocity is it is displacement over time. Displacement basically is under what? Under length. So you have what we call one fundamental physical quantity, another fundamental physical quantity. Their ratio is a derived physical quantity. You can have volume, length times length times length, whatsoever. You bring any force, acceleration, momentum, impulse, energy, power, call any physical quantity other than this 7, it is going to be automatically a derived physical quantity. A derived physical quantity. Okay? So we have fundamental physical quantities, we have derived physical quantities. Derived physical quantities. And the fundamentals are 7. If you know the fundamentals, no confusion, because the rest are going to be derived physical quantities. And the question says, which of the following sets of physical quantities consists of derived quantities only? We have list A, force, velocity, acceleration. None of them are fundamental. Okay, they are derived all. You find none of them to be under the list of the 7. B, speed, work, and distance. Speed is not here, work is not here, but distance basically. But it says only, therefore this cannot be the answer. Distance is the only one. C, distance, which is length, mass, which is again fundamental in the list. Length is here, mass is here, time is here. So you see, all these 3 are under C, and they all are fundamental. Okay? And D, mass, energy, and force. Mass is fundamental. C, all are fundamental. B, distance is fundamental. A, all are derived. So the answer is going to be what? A. The answer is A. Because it says only derived quantities, and force is derived, velocity is derived, acceleration is derived, and A is the choice which contains only derived physical quantities. Only derived physical quantities. The third question, okay, the third question is also related to physical quantities. Okay, it is going to be under the introduction part of grade 7 and grade 8 physics texts. And the question says, the distance from Bahir Dar to Gondar is estimated to be 180 kilometers. Okay, from Bahir Dar, BDR, to Gondar, Gondar DR, let me say. The approximate distance is, okay, the approximate distance is taken to be 180 kilometers. Okay, so the question is, what is this distance in meters? So we talk about what? Unit conversion. Take mass, kilogram, MKS basically, meter, kilogram, second. MKS basically is about fundamental physical quantities of mechanics. Fundamental physical quantities of mechanics. So let's talk about this. When we talk about this, to make things short, let me say kilogram is SI unit of mass. SI unit of mass. Okay? So you have lower values, you have higher values. Okay? You have gram, milligram, kilogram. You can have decigram, whatever, but these are commonly used. And you have, from kilogram onwards, you have quintal and you have ton. Okay? But I need only this because we usually use this. So if you want, this is going to be 1000 milligram, okay, and it is going to be 1/1000 kilogram or 0.001 kilogram. Okay, milligram is 0.001 gram, which is 0.000. I'm changing this one into kilogram, milligram into kilogram. So below 1000, above 1000, basically, and it is going to be 1, 2, 3, 4, 5, 6 kilogram. Okay. So what you do here is you have to know this is 1000 gram, okay, which is 1 million milligram. Okay, but what is important here is you have to know prefixes. Like milli means 10 raised to minus 3, and kilo means 10 raised to plus 3. Okay, there are micro is 10 raised to minus 6. Okay, mega is 10 raised to plus 6. You see, if you know this, your basic unit from which you are going to use the prefixes is gram, because you say milligram, kilogram, megagram, microgram, and so on. Okay, so gram to kilogram is going to be just multiplying by 1000, and kilogram to gram is dividing by 1000, and so on. So you use this to convert mass units from one to the other. The other point is the unit of distance, meter. Meter, you have centimeter. Okay, centi means 1000, so centimeter means 1000. I mean one below, which means 10 raised to minus 2 meter. You have decimeter, you have millimeter, meter, and you have kilometer. Okay, kilometer. So 1 kilometer is 1000 meter. 1 centimeter is 0.001. Is that okay? 0.01, I think, meter. And 1 millimeter is 0.001 meter. Okay, but what is meter is your standard, and you have kilo, you have millimeter, you have kilometer, you have decimeter, you have centimeter, and so on. Okay, these are 1/1000, 1/10, 1/100. This is 1000 times for meter. So the question is, you have 180 kilometers basically. So 1 kilometer basically is 1000 meter. We say it here. So 180 kilometer is going to be how much? Just automatically, it is going to be 1000 times. Okay, the distance from Bahir Dar to Gondar is going to be 180 times 1000 then meter, which is going to be 180 plus 3 zeros, then you have meter. So the answer is going to be A 1800, B 18,000, C it should be like this, yes. C it says 1,800,000 and D 180,000. So the answer is D. The answer is D. Okay, the answer is D. When we come to time, basically to add just the concept. 1 second is the for time. Second is what we take as a standard, and basically you have microsecond, millisecond below that, nanosecond, and so on. Okay, for example, microsecond is 10 raised to minus 6 second. Okay, this is microsecond. Millisecond is 10 raised to minus 3 second, is millisecond. But you can, above that you have what? Minute, 60 seconds. You have hour, okay, hour, which is going to be 60 minutes, therefore 60 minutes. You have day, 24 hours, and you have week, which is 7 days. You have month, 30 days. You have year, 12 months, and so on. Okay, so I think this is a simple concept to understand. You can convert from one to the other. Anyways, this is all about today's discussion. We have seen 3 questions only, but we have seen the basics related to those questions. So you find any question different from this one, but from the same concepts, you can use the concepts and you can answer the questions. Okay, thank you very much. Subscribe, like, comment, okay, so that I can produce more videos. Okay, thank you very much.